Hello guys, this is Dr. Antoine, your coach in data analysis. Today I'm going to show you how you can use non-parametric tests in R. Remember when you want to apply parametric tests, including regression, correlation, t-tests, most of the time there are assumptions that must be made, like for instance, normality and equality of variance. And when these conditions are not met, you may make some mistake in testing your hypothesis, like what we call type 1 error. That means rejecting the null hypothesis when it is actually true, or what we call type 2 error, which means not rejecting the null hypothesis when it is actually false. This is the kind of mistake that you can make when you are testing your hypothesis, and that's why you have to choose a method or a way. You have to choose a method which allows you to avoid those kind of errors. In most of the time, regression, for instance, has assumption of having data which are normally distributed. When you test this assumption and you found that the assumption is not met, you need to find another method, another way of analyzing your data so as to test your hypothesis. And you must be aware that you have to avoid this kind of error. When you are performing your regression analysis and when the hypothesis of normality is not met, maybe you can have some variable which may be significant while they are not significant, or you can have variable which cannot be significant while they may be significant, and that's why you have to choose a better method which allows you to avoid those kind of errors so as to make a good conclusion on your data analysis. Remember, when you are making your research, you have to you have to draw a conclusion that may affect the way people are acting. For instance, when you recommend to do something based on your result, but you must make sure that your results are not false. You must be sure that your results are correct. That's why you have to pay so much attention so as to find a method which are suitable for your data when you are conducting your research. Now we are going to see some method that can be used when your data are not suitable for linear regression analysis. And this method allows you to test your hypothesis based on your theory or based on your prior studies. That's what we want to see here in this presentation. To show you how you can perform non-parametric regression, I'm going to use data that you are familiar, the GDP and FDI. We are going to analyze the impact of FDI on GDP. The data were collected from the World Bank, and we have GDP and FDI for 2020 year data. And now I'm going to just import my data in R. Now you are accustomed to this command. This command is just to import my data in R. And this command also allows us to have numbers, not in the scientific format. This is to analyze the dimension of our data to see how many variables we have, how many observations we have, or country in this case. And this command head here is to just to see the first element, whether our data were correctly imported in R. And as you can see here, we have a country name. Here we have a GDP and we have FDI. And just this command, we need to analyze whether we have missing data in our data sets, and this library question R allows us to just to analyze the number of missing data and the percentage of those missing data. Now, as you can see here in this the result of this command, this one. In GDP 2020, we have the 44 missing data, which represent 9%. FDI, we have 22 missing data, which represent 8%, but in the country name, there is no missing data. Now, remember, I have said in data preparation, in the video related to data preparation, I have said that when there are many ways of dealing with missing data, maybe you can replace the missing data by by mean or median or mode, but you can also delete your missing data in your data set. Now here, sorry, I decided to delete missing data in my data set. Okay, now friends, now I have deleted missing data in my data set. Now, the first thing that I need to see is to check whether our data are normally distributed or not. In this case, I can use Shapiro test. Now first I'm going to test whether FDI is normally distributed in or not. Now, as you can see here, FDI is not normally distributed. Remember, the null hypothesis is that the data are normally distributed, and when the p-value, this p-value is less than 5%, we conclude that our data are not normally distributed. Let's test GDP. Okay. You can see here also GDP is not normally distributed. As you can see, the p-value is less than 5%. Okay, now this may be a problem when you want to use, for instance, parametric test, because remember one of the conditions that we have to meet when you are performing parametric test is normality, because when data are not normally distributed, they may affect the result of our analysis. Now, this library performance allows us to locate where we have those outliers. Remember, maybe you can be asked to check what are those countries which have missing variables, which have outliers, or which have high observations or the lowest observations when you compare when you are comparing those observations to the majority or the mean of these observations. Now let's locate those the positions of those countries with higher or outliers. Now you can see these are the positions of those observations. You see, we have here 89 outliers detected. Now, when I want to see those countries, just I need to copy these positions, and with this function here, I can have access to those. And this is non-parametric one. Okay, now I can see the positions. Here with this command, I can just see the countries. As you can see here, we have 9 names of countries, and we have also GDP and FDI. And as you can see here, let's show you. As you can see here is the country name, and this is GDP and FDI. These are all those observations, 89, as you have seen it, which are considered as outliers. We can also test on FDI. FDI, we can also test it. Here is we learn it just to locate the position of those outliers. And as you can see here, those are the positions which are considered as outliers. You see here we have 87, while in the GDP we have 89 countries which are considered as outliers. And when I want just to see those countries, I do the same. I copy these positions and I paste here. And with this command, I can see those countries. Now, let's first learn linear regression, and you can see the coefficient of FDI. Let's first we need just to see what is the difference between our models when I use linear model or non-parametric regression. Here, this is how we learn the linear model. here, and I make the summary of the model, and I need to see what is the coefficient of FTI when I regress FTI on GDP. As you can see here from linear model, the coefficient of FTI is 66.4465, and it is significant. As you can see here, it is significant, and the model also is significant. This means the FTI explained 89% of the mean change of GDP. And let's get this coefficient, and then we will compare this coefficient with other results from other models, which is this number. From this linear regression, you can see that the increasing 1 unit of FDI will increase GDP by 66.6465. Now, when, for instance, you can check assumption. Linearity of residual is what the most important assumption in linear regression, but you can see this assumption is not met. That's why, look, normality of residual, this assumption of normality of residual is not met. That's why you have to find another method which maybe can give us better result. Now we are going to the first non-parametric regression you can use is the Kendall-Siegel non-parametric linear regression, and this method is used when you have two variables, one independent variable and one dependent variable, and this method is robust when a dependent variable has outliers, which is the case in our data, because when we tested the GDP, whether GDP is normally distributed, we found that GDP is not normally distributed, and this method can fit well our linear model, because we are analyzing the impact of FTI on GDP. Now, before we perform this regression, we need to have this package. When you don't have it, you have to install the package. To install the package, you go here, you see here package, you open this package, and you see here install, this one, install, and you type the name of the package you want to install. Now, just to show you how you can install the package, but I'm not going to install because now I have already installed it. That's just to show you how you can install the package. Maybe you may be working and you found that you do not have package that this is required, and just is how you can install the package, and you must be connected to internet. But here you will see where you can have access, where you can tap your package, and then you click on install with dependencies. The machine is taking much time because I am using many software. Okay, let me see if I can continue as I have installed. Now let me see if I can run this model. Now this is the summary of the model. Now you see the machine is not working, the computer is not working because of this comment. I have to wait a moment, so I have to wait a moment because of this comment I made. It's causing problem to my machine, to my computer. Okay, now what I said, now you can write the comment here when you want to install your library. You see, you tap like that, and then you must be sure this is active. Install dependencies, and here you click on install, and you finish, and you have to wait until the package, your library is installed. But now I'm not going to install. I just click cancel. So as to cancel these commands, because I'm not going to install it now. Okay. It is just to show you how you can install the package when you have a problem of missing the package you need to analyze your data. Now I'm going to create my model, and you see the comment. Now I'm going to see the results, the summary of the model. Now, as you can see here, we have this coefficient of FDI is insignificant. You see now those stars here, and when you can see, you see the coefficient is around 40. We want to copy these coefficients just because remember in linear regression we found 66. You see 66. Now you see now here we have 49. Regression. This is one kind of linear regression, and you can use this when you see that your dependent variable is not normally distributed, or when your dependent variable has outliers. And this is the confidence interval. You can see the minimum can have as coefficients, and the maximum can have. Now the minimum can have is this one, 37 and 44. Okay, this is the first kind of non-parametric regression, and you can see another kind of regression, which is the Quantil regression. This is used to estimate the impact of increasing one by one unit independent variable, and it allows to measure the impact of independent variable on the quantity you are analyzing. Suppose that you want to see, for instance, how increasing FDI affect 50% of the country, the median, or 45% or 75%. This is what we call Quantil regression. This can be used, and it may be used for this kind of regression, because, for instance, when you want to see how 20% of the population is affected by the treatment, you can use this regression, because when you use linear regression, you are considering the mean change of dependent variable, but you cannot specify exactly which quantity or which population is. How you cannot evaluate how a group of population can be affected your treatment. Now, when you use 50%, the result may be the same as linear regression, because remember I said now linear regression is considering the mean. Now 50% is the mean. Result may be the same, but which is important is that we can specify what we want to analyze. If we want to see, for instance, 20% of the population, 50%, 75%, this can be done with Quantil regression, but you cannot use it you cannot get this result when you use, for instance, linear regression. As you can see here, the result here is 61. The impact of increasing 1%, 50% of the population will be affected. Will be in 50%, increasing 1% of FDI will increase 61. But when you increase 1 unit of FDI, 50%, the GDP of 50% countries will increase by 61.6. What does it mean? When it increase by when you increase independent variable FDI by 1 unit, in 50% of the country, GDP will increase by 61.6%. Well, that is what it means. Suppose that I want to see how 20% of the countries will be affected. I change here, I put 20%. What is the result? You see now, 20% will have an increase in FDI of 51, so 0.7. You see now, you cannot have this, you cannot make this kind of analysis when you use linear regression. It is the interest of using Quantil regression. Let's see how 75% is affected by increase of independent variable by one unit. You can, as you can see, we can specify the part we want. You can see here 69%. Now let's see, for instance, consider 40%. Let's see if it can be done. Now, as you can see, this is a better way of analyzing your data, which cannot be done with when you use, for instance, linear regression. Let's consider our 50%. Oh, this is another kind of linear non-parametric regression that you can use when you are analyzing your data. And as you can see, it allows you to specify the dependent variable, the part of your dependent variable you want to analyze. As you can specify the percentage, where they want 10%, where they want 50%, where they want 20%. As you can see, on the result here, you can specify the percentage you want to analyze, and this cannot be done when you use linear regression. Okay, now we just need to learn low-based regression. This also can be used. Low-based regression can be used also. Remember when I was talking about how to perform the low-based regression, I said there are many packages that can be used when you want to perform low-based regression, and now we are going to use this package mass, and you can see how this low-based regression can fit our data. Remember, low-based regression has the power of down weights those observations which are considered as outliers. When there's no outliers, low-based regression and linear regression have the same results. But when there is outliers, low-based regression has this quality of this power of downweighting those outliers so as not to have impact or not to have influence on the result. Now, as you can see here in low-based regression, the coefficient of FDI, when we are reducing FDI on GDP, the coefficient is this 61%. Now it is not very far from our normal regression. Okay, as you can see here, it is the result is near from here. When you're in quantum regression, here you can see, especially this one, this quantum regression. When we consider 50%, you can see it is very near. Now, the last type of regression, non-parametric test you can use is generalized additive model. This also can be used. It is a kind of non-parametric regression. This here that you can use when you are analyzing your data. Let's see the results of I done the summary of the model. Now here, okay, now as you can see, the parameter of the model is, as you can see here, it is the parameter of FDI is significant, as you can see, and the coefficient is this one, 66.61. Now, as you can see, it is almost the same as the coefficient we got in linear regression, because in linear regression we got, let's show you in linear regression. Look here, linear regression, we got 66.46. And here we have 66.61. Now, friends, those are kind of linear non-parametric tests that you can use when you are performing our data. And when you found that the condition of applying linear regression are not met, you can use non-parametric tests based on what you want, based on your hey, based on your purpose, because now we are here, the main purpose is to analyze the impact of FDI on GDP, and we found that linear regression cannot be used, and we found another way of analyzing this impact, and you have seen many ways of analyzing, testing, and hypotheses when you have theories or every previous studies which state that FDI have impact, significant impact on GDP. And now, remember, when you are testing your linear regression, you found that you cannot use linear regression, and I show you many ways of testing this hypothesis or these assumptions, which avoid you to make the mistake, the type 1 and type 2 errors that I explained in the video. Okay, friends, this is the end of our presentation. If you like this video, you can share it. Don't hesitate to subscribe to our channel so as not to miss any of our video. Okay, friends, for next video.